Okay. Alright, so today's lesson is actually mostly going to be examples, and so you'll see that on here. We talked about what happens when I have a central angle, how the angle and the arc are equal. We talked about with the inscribed angle, the angle is half the arc. So now we're going to look at what if it's neither. What happens if they cross in the circle but not at the center? Or what happens if they cross outside of the circle? We're going to see that. And so we're going to look at some different scenarios, and this is basically going to give you the formula for each scenario, and then we'll do an example. And tomorrow in class, or Thursday if you're second or sixth period, then you can expect to see more examples and more practice of this. Okay, so let's look at the first scenario. The very first scenario we've got here says that we've got two secants or chords, whichever they may be, that are intersecting, but they're not intersecting at the center. So take a look, notice that this point where they're crossing is not the center. Okay, and if that's the case, then what I have to do, it tells me right here, we're going to take half for angle 1. So let's mark it in here. Angle 1 is here. Okay, angle 1 is going to be half of the arc AC plus arc BD. Okay, so notice angle 1 I know has a vertical angle, right? And this is the way I like to describe it. With the vertical angles are still equal. They're always equal. And so their arcs have to be related as well, because these are the same measure. And so if I average arc AC with arc DB, which is adding them together and dividing by 2, that's what half does, then I'm going to come up with the measure of angle 1. Okay. Now if I wanted angle 2, we're going to have to find the two arcs that go with angle 2. So I'm going to mark angle 2 in a different color here. Okay. So the arc that's across from it and the arc that's across from its vertical angle, those go together. So I would average those two arcs, and that would give me the angle. Okay. So let's do the example that they have there for us. They want us to find the measure of angle 2 if the measure of arc BC is 30 and arc AD is 20. Now notice BC and AD don't go with angle 2, they actually go with angle 1. So what we also know that if we can find angle 1, we can find angle 2. Okay? So we're going to take our formula from up above, and I'm going to average these two arcs. So we're going to say 30 plus 20 is 50, and I want half of that. Okay. And when I take an average, we know it always is going to be exactly in the middle. That's what an average does. Okay. So the average, 30 plus 20 divided by 2, would give me 25 degrees. So angle 1 is 25 degrees, and it's asking for angle 2. So to find angle 2, of course, then we have a linear pair. And so 180 minus that 25, our answer then would have to be, so my answer is 155 degrees. Okay? So that's what we do if they intersect inside my circle, but it's not the center. We find the average of the arcs. Okay, let's look at scenario number 2. Now this one is actually very simple because it works just like an inscribed angle. If I have a tangent, we know the tangent only touches the circle at one point. And so if I look at this picture right here, it's showing you that we've got a tangent and it's touching my circle only at B, right? It's touching my circle only at B. And so it makes an angle at B. Well, that means the vertex, which is B, is on my circle, and which is exactly what we talked about with an inscribed angle. And so it's always going to be half of its arc. And that's all this is saying. It's just, it looks a little bit different because the arc that's inside of that angle is this whole kit and caboodle right here. Okay? So we've got arc BEC right there that goes with this part of the angle. If we wanted to find this side of the angle, it would be half of that. Now notice the entire circle is made up of those two different arcs, right? And so together it's going to add up to 360, and half of 360 is 180. So that's one way I can know for sure this works out. Okay, let's go on down to the next one. Let's do our example. So if this is 102 degrees, notice I could totally extend that to see what's happening here. That arc is 102 degrees. Well, that's going to mean that this other side would be 360 minus the 102. So that would give me 200 258. Okay, so 258 represents arc ADB all the way around there. Okay, and so this angle ABC, which is what they want, is going to have to be half of that. And so that angle would come out to 129 degrees. Okay? Pretty simple. Just think of it as an inscribed angle, and you'll be good. All right, let's move on down and take a look at the next set of scenario. Okay? So far, everything has occurred either in or on my circle. What happens if it's outside of my circle? Dun, dun, dun. Okay, scenario number 3 is an exterior angle, and I want you to notice every one of these has to do with a half. Okay, the difference is, remember when we got to an inscribed angle, it was smaller than what it was if it was a central angle. Well, if I keep pulling that outside of my circle, if I go further and further out, the smaller it's going to get. And so what happens with these, and it doesn't matter what it looks like, whether it's two secants or secant tangent or two tangents, like the 3 different pictures they have here. It doesn't matter which one it is. I'm going to subtract the 2 arcs that are inside of it, and then I'm going to take half of it. Okay, so subtract the arcs and take half. So if I'm looking at these 2 secants, those 2 arcs inside, I can clearly see which one is the biggest. It's always the furthest one out. So I would do DE minus BC and take half. Okay, so let's work this example down here. They gave us 120 and 50. I'm going to subtract those. I get 70, and I will take half of 70, and that's going to be this angle right here. Half of 70 is 35 degrees. Okay. This next one, my arcs that go inside of that, it's got a secant and a tangent, so one of them just barely touches. Okay. So arc BC and arc DC are what I'm using. DC is clearly the larger of the 2, and so I'm going to subtract DC minus BC and take half. Okay. So now this one actually is working with x, and so it's just going to be some algebra in there, but I can still work it out. So we would say 6x minus 2 minus 78. Oops. Divided by 2. Okay, big arc minus little arc divided by 2 equals my x. So we've got to do a little bit more algebra here. I would start by multiplying both sides by 2, and we would come up with 6x minus 80 equals 2x. So 6x minus 80 equals 2x. Okay. And then when we move the 6x over, we'd wind up with negative 80 equals negative 4x. Divide both sides by negative 4, and x is 20. Now if I plug that back in, I'll see that it works. Okay, I can see that 6 times 20 is 120 minus 2, which would be 118, and 118 minus 78 divided by 2 is going to give you that 20 degrees. So it will work out there. So using the formula, this one just had a little bit of algebra. Let's take a look at the last situation. 2 tangents. The entire circle is going to make up those 2 arcs then. Okay, and so we've got the big arc and the little arc. I'm going to subtract and take half. Okay, so in this case, the big arc is x. Now notice they didn't give us the little arc, but I know that it's going to be just 360 minus the x, right? So let me show you the way I work this out. I'm going to leave it in the same form that they did. I'm going to say 25, so it matches that formula right up above, is equal to 1/2 of x minus, and I'm calling this whole thing 360 minus x. But I want you to take a look. You got to be careful here. 360 minus x. So I actually wound up with double parentheses there. The reason I was very careful there is because this negative is going to go to the 360, but it also goes and changes that negative x to a positive x. So we wind up with 25 is equal to 1/2, and then in parentheses becomes 2x minus 360. Okay, so if I take half of that, of everything that's inside those parentheses, we now have 25 equals, I'm going to come on down here below because I'm running out of space. 25 equals x minus 180. Okay, and if I add the 180 to both sides, then we've got our answer. And my angle comes out to be 205 degrees. Okay? All right, so hopefully you're able to understand these examples, and in tomorrow in class you can expect not only a pop quiz, but you can also expect to see some more practice with this.